Right, this next example is a thing pair share. So please go ahead and pause and resume after you've given this one a try. So the table below has the data speeds for 5 airports taken at random from Sprint and T-Mobile. So here we have 5 airports denoted by an airport code. And then here we've got Sprint and T-Mobile with their respective speeds at those airports. So construct a 95% confidence interval for the data speeds of both wireless service providers and make an argument for which is the better service. All right, so let's first take a look, I guess 30,000 feet view of what we're doing. We're actually creating two confidence intervals. One confidence interval for Sprint and the other confidence interval for T-Mobile. All right, so let's see what information that we were given. Do we know anything about sample size? Well, the sample size is 5 because we have 5 airports. Um, let's see here. We don't know anything about the population mean airport speed for Sprint. And we also don't know, shouldn't put it equal like that. We also don't know the mean airport speed for T-Mobile. What else do we not know? We don't know what the standard deviation is for Sprint and T-Mobile. Let's see here. We do know that the confidence level is going to be 95%. Okay, which means we're going to have a significance level, 0.05. And dealing with confidence intervals, it's always going to be two-tailed. So we're going to have to take the significance level divided by 2. So that means we're going to have an area of 0.025 in each tail. All right. Okay, so what is it that we need? What we need is we need a confidence interval for Sprint, and we need a confidence interval for T-Mobile. All right, so we need both. So out of what we need, do we have it already? And I don't see anywhere that we've already got, X bar or our margin of error. So we're going to have to come up with both of those. All right. So how can we get X bar for Sprint and X bar for T-Mobile? Well, this is where the calculator or spreadsheet software could help. We're just going to use our calculator here. Um, and, so since we're dealing with the situation where the population standard deviation here is unknown, we're also going to need the sample standard deviation for Sprint and the sample standard deviation for T-Mobile. We're going to need that as well. Okay. So don't let me forget. Okay. All right. So took the liberty, I think, of going in and putting these values in already. So on the Texas Instruments, I put Sprint in list 1 and I put T-Mobile in list 2. And for the NumWorks, I went to the statistics app and I put Sprint in the V1 column. And then I went over to the V2 column and I put in T-Mobile there. Okay. So to get our X bar and S, just need to go to the stats tab here. And then we can go down to Here we've got sample mean and sample standard deviation. All right. So over here with the Texas Instruments, here. All right, so with Texas Instruments, we need to go to one variable stats. So go to the calc menu. Let me do two variable stats. Let me see if that's going to work well enough. So we're going to have list one and list two. So this kind of lets us do one variable stats on two lists at the same time, but it doesn't give us everything that one variable stats would. But I want to see if it'll give us enough. Um, so X bar is the mean of the first list. Let's see here, which should have been 12.74. All right, I got a bit of a discrepancy I got to figure out. Actually, that 12.74 is what I would expect it to be. Let me see if I made a mistake here. And let's see here. 13, 30.4. This third one, this one should be 15.2. Okay. Now let's do two variable stats. Okay. Now I've got parity between the two calculators. All right. So you can see here, both of them have the same sample mean for sprint, 12.74. And then this Y bar is the sample mean for the second list. So we have 11.28 and 11.28. So let me go ahead and write those down. So we've got 12.74 here and 11.28 there. Now let's see what sample standard deviation we have for Sprint and for T-Mobile. Okay, so let's go here. Yeah, it gives us that. So we have 11.464. All right, let me go ahead and write that down. So we have 11.464 and standard deviation for T-Mobile. So if we scroll down, it should give us SY. So this is the sample standard deviation for list Y. That's 5.901. Oops. 5.9. I'm going to put 00 and just keep going like that, just to show that it's actually a longer decimal. Okay, so now for both, we have our X bar. All right, but what we need for both of them now is we need the margin of error. So the margin of error equation is going to be same, just maybe the values will be a little different. So it's going to be the margin of error is equal to T alpha 2 and then times sample standard deviation by the square root of n. We're going to have the same thing on the other side, but this will be for T-Mobile. All right. Now, regardless of this being for two separate calculations, the T alpha 2 score is going to be the same for both. So I'm going to just put one distribution here kind of in the middle like that. And it's going to be two-tailed because we're dealing with a confidence interval. Um, but this will be our positive T critical value. And here's our negative T critical value. And the critical value separates the confidence level, which for us is 0.95. Okay, so it separates the confidence level from the significance level, but we had to divide the significance level into two pieces because we had to put half on one side and half on the other side. All right. And since we're dealing with a student's T distribution, we need to calculate degrees of freedom. So degrees of freedom is equal to the sample size minus 1. Sample size was 5. So we're going to have 4 degrees of freedom. So now we need to use an inverse distribution function in order to convert an area to a number line value. So I'm going to work on trying to convert this area in the tail to the adjacent critical value here. Texas Instruments natively, it's going to give us that one. It'll be a negative number, but it'll pretty much be the same number. All right, so let's go back over here to the Texas Instruments and let's go to the distribution menu. And we'll go ahead and use the native inverse T function. So we have an area of 0.025 with 4 degrees of freedom this time. Enter. Okay, so we're going to get like a positive 2.776. And I'm going to go ahead and store that. Actually, not yet. I just cleared that. All right, let me do it again. Nope. Yeah, let me hit enter. And let me multiply this times -1 to make it positive. And then now I'm going to store that in variable t. So that's a t-score. Okay, so now let's go over here to the NumWorks calculator and we'll click on Home and we'll go to the Distributions app. And let me go ahead and back out all the way. So we want to go down to Students T, 4 degrees of freedom. And I want the area on the right. And it's 0.025. Yeah, 2.776. Now I'll go ahead and store that in variable t. So I'm going to hit store and then shift alpha t like that. All right. All right, so 2.776. So let me come back over here and just put that our T alpha 2 score that we need is 2.776. All right. So we have everything we need now. We have the sample standard deviation for each of these. We know the sample size, okay, which is going to be 5. And the T alpha 2 score we just calculated to be this 2.776. So I want to, use the fully accurate versions of each of these numbers. I'm already kind of prepared to do that with the Texas Instruments calculator. And I'll go ahead and calculate the error for both of these, I think. The margin of error is going to be the t-score times the sample standard deviation. So I'm going to do sprint first. So I'm going to come over here to variables and then go down to statistics. And then I'm going to grab the sample standard deviation for the first list, which was the sprint data. And I want to divide that by the square root of our sample size, which was 5. And that gives me a margin of error of 14.234. And let me do the same thing. But let me use the sample standard deviation for T-Mobile. Which is this SY. There we go. Right arrow, right parentheses. Okay, and there's the margin of error for T-Mobile. So let me go ahead and write those down. 14.235. So here, $14.235, and the margin of error for T-Mobile was 7.327. 7.327. Let's go ahead and do that. Let's do this with the numbers calculator. And I already stored this value in T, but what I need is I need the standard deviation. So I'm going to go back up to the statistics app, and I'm going to come down here to the sample standard deviation. And what I'm going to do is I'm going to store this value in capital S, and then the other one I'll store in lowercase s. So disadvantage of the numbers calculator is it doesn't store these in this variable that you can get to, like we can with the Texas Instruments. But we can store things in upper and lowercase letters. So let me try it here. Haven't tried it with upper and lowercase actually, but I think it'll work. So let's store this one in capital S. I'm going to hit Shift, arrow, and then Shift alpha 5. That'll let me do a capital S. And then we take this one and let me store that. And now instead of hitting Shift alpha, I'm just going to hit alpha and then 5, and that should put a lowercase s. Okay, it looks like that worked. So now in order to do my calculation, I want to come out. I want to go to the calculation app. Let me clear this. And let's do the margin of error. So I need to put capital T times, and then the standard deviation was a capital S divided by the square root of 5. Okay, 14.2346, same answer we had with the Texas Instruments. And then I'll do the same thing. Except now I'm going to use lowercase s, so I'm not going to hit Shift first. I'm just going to hit alpha 5, that gives me a lowercase s divided by square root of 5. 7.327. All right. So I know in a previous example, I wasted a little bit of time trying to find maybe where all of these variables were stored on the calculator, but a little bit of reading and I couldn't find a place where you could get them. So you just have to store values that you want to use. You want to store those into a variable. Um, okay. So we got these two margins of error, which means now we're going to be able to make our confidence intervals. So for sprint and for T-Mobile. So for sprint, it's going to be 12.74 plus and minus 14.235. And for T-Mobile, it's going to be 11.28 plus and minus 7.327. Okay, so you'll notice that 6.23. My answers now are a little bit off from not really that bad. They're pretty close to what I had earlier. I think I just got kind of lucky. The numbers didn't seem to change too much. But I think when I calculated these answers previously, it was with using rounded values of the sample standard deviation. But generally, you want to calculate it the way I just showed you. Okay, so, what do we got going here? Well, if you were going to visit, these airports with these mobile phone carriers, which would be the best to have when you're traveling on an airport? And I'm going to say that it would be T-Mobile. Why T-Mobile? Well, you may notice that T-Mobile has a slower average speed um, than Sprint. You might, well, I want the fastest speed possible, so I'm going to go with Sprint. But here's my thinking, is that notice that this confidence interval for Sprint, oops, come on, there we go. This confidence interval for Sprint, let's see, it's going to go from a mean here of 12.74, and then we're going to add 14.235. So that'll give us 26 point something, right? That's the upper bound for our confidence interval. And then we're going to subtract 14 to go this direction. We're subtracting error. And so that'll give us a value of like -2 on the lower bound. Well, you can't have a -2 speed, but you can have 0 speed, meaning you have no connection at all. So the fact that you have no connection speed at all, maybe makes Sprint not such a good idea for these airports. Whereas if we look over here at T-Mobile, and here we have a mean of 11.28, and if we add error to that to get the upper bound of our interval, that's going to be roughly at 11 plus 7, which will be 18 and some change. And then if we subtract error to get us the lower bound for that interval, it's going to be 11 minus 7, which is approximately 4. So notice that 0 is outside the interval. So what this means is that if we go with T-Mobile, we'll always have a connection. Even if the connection is slow, at least we'll have one. Whereas if we go and use Sprint, there's a chance we're going to have 0 connection speed and we won't have internet connection at all or cell phone service at all. Okay. So that's where, you can get some interpretation out of the calculation of these um, confidence intervals. And here we did two confidence intervals kind of at the same time, and it really wasn't that much work because we could use the calculator to do most of it for us. And between these two, we just had to create one student's t-distribution because the t-score was the same, and the t-score was the same because the confidence level was the same. We're calculating confidence intervals based off of the same level of confidence. So the t-critical score would be the same for both. Okay, let me know if you have any questions.